Hello everyone. In this lesson, or this video, I'm going to go over evaluating inverse trig functions, in particular those cofunctions, cosecants, cotangents, etc. And just some ways of approaching them and how to evaluate them. So for example, inverse cosecant of -1. Now if you remember from other sections where we talk about finding inverse functions, we could say this is equal to some value theta. And that could be x, but I like to use theta. So I'm going to say, because of that, I can say this is equivalent to saying cosecant of theta is equal to -1, just by definition of inverse functions. If that's true, if we recall that cosecant is equal to 1 over sine, then I can say this is equal to sine of theta is equal to 1 over -1. In other words, I took the reciprocal of -1. Now for simplicity, 1 over -1 is still -1, so that's what I'll say. And the reason I changed back to sine is it's just something we're more used to dealing with. More often than not, we can recall the information we want on sine, cosine, etc. better than we can recall from cosecant and cotangent. Usually, and also they're just used more often. Now before we get too far, we want to remember that since we are originally dealing with cosecant, we have to consider the domain that this is defined upon. And that's going to be from -pi/2 to pi/2. This is going to help us find the quadrant that we're in. In this way, we can determine if the overall answer should be positive or negative, etc. Or in more greater context, what the most specific angle is, depending on quadrant. So cosecant is again defined from -pi/2 to pi/2, and that is from, I should say that's relegated to quadrants 1 or quadrants 4. So we know we're in one of those two quadrants. So let's continue this. Now, because sine is negative, we have to consider where is sine negative. Sine is negative in quadrants 3 and 4. So we can see the overlap is here in quadrant 4. So this means that this theta is in quadrant 4. So let's continue. Now we're looking at sine of theta is equal to -1, so that means one thing I can do is I can set up a triangle and say, well, what I tend to do is I'll think of it as 1 for now. The negative just tells me what quadrant, helps me to determine what quadrant I'm in. So if this is theta, that is opposite over hypotenuse, excuse me, sine is opposite over hypotenuse. Now this leaves us with, well, what do we make our third side? And this is kind of confusing because it's unusual that our hypotenuse and our legs are the same. We're used to the hypotenuse being the same, or being the longest side. So while normally a triangle helps us out in these situations, this is a very specific value. We need to think, where is sine, and since I said I'm going to think of it like a positive 1 for now, where is sine equal to 1? We can refer back to our unit circle. And again, the reason I'm doing this is because the triangle didn't work out. It's again giving us a situation where it doesn't make sense. So we can refer back to our unit circle, where is sine equal to 1, and that's at pi/2. So that means that if our angles or if we're dealing with the angle of pi/2 in quadrant 4, then you can either say this is a negative pi/2, or you might have said, well, I can just think of it as sine of theta gives me a -1. That would put me at the line or the angle 3 pi over 2. And either one is correct. So two ways of thinking of it. Let's try the same thing with this one, inverse cotangent of root 3. So again, since I'm dealing with cotangent, I'm using the interval from 0 to pi. So if this is equal to some value theta, I can say then that cotangent of theta is equal to the square root of 3. And like I said, since we're used to dealing with sine, cosine, etc., the cofunction of this, since cotangent is 1 over tangent, I can say then that tangent of theta is equal to 1 over the square root of 3, the reciprocal. And since it's positive, right now we've determined that we could be from 0 to pi, which means in quadrants 1 and quadrants 2. Tangent being positive, where is tangent positive? That's in quadrants 3 and quadrants 1. So this means we are in quadrant 1. So now we want to figure out where is tangent of theta equal to 1 over the square root of 3. Fine, sketch my triangle. I'll say theta's there. So opposite over adjacent. Well, from this I can make my hypotenuse is 2. This is a 30, 60, 90 triangle. And if you recall, now it's just a matter of matching it up. In our 30, 60, 90 triangle, this angle in here is 30 degrees. This angle is 60 degrees. Or excuse me, I should have that reversed. Let's try that again. 60 degrees and 30 degrees. So this means that my theta matches up to 30 degrees, and since we're in quadrant 1, 30 degrees just stays 30 degrees. I don't have to, modify it to say what's 30 degrees in quadrant 2, what angle does it correspond to. So we say our theta is equal to pi over 6, or you could say 30 degrees. Lastly, let's say this one. So inverse cosecant equals to negative 2 root 3 over 3. I'll say it's equal to some value theta, and negative cosecant corresponds to the interval negative pi over 2 to pi over 2. This means I'm in quadrants, potentially anyway, 1 and 4. So I'll say this is cosecant of theta equals negative 2 root 3 over 3. And instead I'll say, well, let's make this 1 over sine. Or I should say, since cosecant is 1 over sine, I'll say it's equivalent to say sine of theta is equal to the reciprocal, which is negative 3 over 2 root 3. Now if I want to make a triangle off of this, and before I get to that, excuse me, if I want to take, if I'm thinking my sine is negative, where is sine negative? That's in quadrants 3 and quadrants 4, so my overlap is in 4. So we know we're in quadrant 4 now. Now I need to think, what triangle does this make? This is my theta. Then I have opposite over hypotenuse, so this is 2 root 3, and this is 3. What triangle does this match? What triangle does this correspond to? One thing that might be easier, especially when you have angles or hypotenuse and legs that you're not used to, or that don't fall into one of our predetermined triangles, 30, 60, 90, 45, 45, right? What I like to do is, let me rationalize this, get the radical out of the denominator. And maybe that will clear things up. So now I have 3 root 3 over 2 times 3. And that becomes square root of 3 over 2. So another way I can think of it. And so if I build the triangle based off that, again talking about sine, so I have square root of 3, which means this side is now 1, we can see, okay, it's a 30, 60, 90 triangle. Which means that the way it's drawn here, now it's not drawn to scale, but the way it's drawn here, I can even look back at my old one. The angle, it's the angle between 1 and 2. And that is 60 degrees. So we're saying that theta is 60 degrees or pi over 3. Now, since we're in quadrant 4, this means that we could say it's either negative pi over 3, which means we just go the opposite direction, or we could say if we want to keep it positive, and I'm going to move my triangle here, going the other way around, going this way. This means theta also could be 5 pi over 3. That would also put us in the fourth quadrant. So this is the way we can approach inverse cofunctions. Hopefully this gives you a way of solving these.